to Engineering 151. In today's video, we will guide you through lab number 2, tension testing. First, I want to remind you that you need to complete your pre-lab before beginning the actual lab. For the pre-lab, you will need to find the reference values of both the 4130 steel and the 6061 T6 aluminum to calculate the expected values of each metals respectively. The goals of this lab is to generate stress-strain diagrams using Excel for metal samples experiencing pure tension. In order to determine stress-strain relationships, tensile testing can be used. This test consists of slowly pulling a sample of material in tension until it breaks. Rather than measuring cross-sectional dimensions while conducting the experiment, we will measure stress and strain based on the original sample and the final specimen. For this lab, you will need a 6-inch flat tension specimen of both 4130 steel and 6061 T6 aluminum.
In this lab exercise, only the teaching assistant will operate the Instron 3369 universal testing machine. For both the aluminum and steel samples, the UTM software will simultaneously record the force information during the test. The specimen will be pulled until it fails. The data will then be recorded and plotted to develop a stress-strain diagram using equations that define stress and strain as a function of force and deformation. After completion of the lab exercise, you will need to analyze your data by determining and tabulating the percent elongation, modulus of elasticity, yield strength, and ultimate tensile strength. Using Excel, generate 2 separate stress-strain graphs for each sample. Using the data from the extensometer, show the linear portion of the curve to just after the yield point. On the graph, label important regions, areas, and/or points on the plot that correspond to the data that was calculated. Remember to include the appropriate title, axis label, and unit of information on graphs. Using the crossbeam extension data, plot the entire response curve from initial loading to failure. In order to calculate strain using the crossbeam extension values, assume an initial length of 4 inches. Remember to label this graph as well. It is important to note the assignment is to create stress-strain diagrams, not force deformation diagrams. After a lab experiment has been finished, complete the data sheet and the discussion questions.